Hi everybody, this is a Sec 2 science video. What we're going to do with this video is we're going to talk about the solar system. This was the topic of our Zoom class that a few of you got a chance to participate in. So if you were there, that's great. There's some new ideas, so you should watch this video anyway. And if you weren't there, I will try to recap a little bit of what we talked about. So you've probably heard of the 8 planets of our solar system that all orbit around the sun: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. You may have even heard this little sentence to help you remember them in order. My very eccentric mother just served us nachos. I've seen that on the internet for a while. I always like to ask you to come up with better little sentences to help remember. So if you can, hey, go for it. Normally I'd ask you to do that. I obviously can't now, but so I checked the internet. There's some websites that generate them. And they came up with this: mutant vampiresses evaded maggoty jerseys sans uptight needles. I don't really see that catching on. So if you can come up with a better one, hey, good for you. So one more thing to know about the planets is that we put them into different categories. The first 4 we're going to call terrestrial planets, and the next 4 we're going to call gaseous planets. And they are separated by a big collection of space debris, big rocks that are all floating around at this region called the asteroid belt. Okay, so now we know the 8 planets. Pluto, by the way, is no longer considered a planet. It stopped being considered one in 2006. But you've probably seen images like this of the solar system. And what we talked about in the Zoom class is that there's all kinds of problems with this particular picture. About all it's good for is showing you the order of the planets and what they look like from a distance. But the sizes are way off. Jupiter is the biggest planet, but it should be much, much bigger than Earth. And the sun should be much, much bigger than everything here. Okay, that's one problem. The other problem is that the distances between the planets are completely off. They should be way, way further apart than what you see here. So I'll show you a little bit about that later on. And a third problem is that all the planets take a different amount of time to orbit the sun. Is it really realistic to have them all in a straight line like this? No, it isn't. I mean, it's technically possible, but it'd be like the most rare thing you could possibly imagine. And it would also be the most evil LCM question I could think of. Calculate how long it would take all the planets to be completely lined up. Ugh. So forget that. But we use this to talk about what it would look like if we were to show you a scaled version. So to do that, I found a website called If the Moon Were 1 Pixel. And a pixel is just one little light on your computer screen. So if that were true, if the moon were 1 pixel, it'd be incredibly small, just about the little tip of my cursor here. And the sun would be this big. So we found this website. We scrolled sideways till we reached all the planets, or some of them, and then we got bored. But there's a counter on the bottom that counts how many kilometers you were actually traveling in real life. So it's a pretty cool way to look at it, and I recommend that you try it. There's a link in the description if you haven't gotten to see this website yet. And they put up a bunch of little funny comments along the way too, so it won't be that boring. But I guess the most exciting way to go through space, we called this a virtual field trip. If we wanted to do it as a real field trip, we would probably have to ask Ms. Frizzle. We had a big chat about that as well. She famously took her class on a field trip to all the planets. They visited them all in about an afternoon, I imagine. Another reason why that show is not very realistic, but it did list all the planets. And I do have to say, I really do like her hat. I would wear that if I had it. So we're not going to do this magic school bus style. This time I'm not going to abandon you at Jupiter like she did. I'm going to show you all 8 planets. And I think it's important that we do this because a lot of you were not able to join us for the Zoom meeting. I know you had other meetings going on. I should have coordinated it because you know what they say. If you want to have a trip to outer space, you've really got to plan it. Thank you. That's right. These videos come with laugh tracks now. Very exciting. Okay, so we're going to do this differently today. You may have seen this big orange round building if you've ever driven up to Carrie in Montreal, the famous orange julep. I've actually never been here, so I didn't take this picture. I've driven by it my whole life, but Apparently they sell, well, it's not orange juice. It's some orange vanilla-ish, ice cream-ish, milkshake-like thing all blended together. Maybe you'll like it. I don't know. Maybe you've tried it. Sounds better than cilantro to me anyway. But let's see. Its diameter, I looked it up, is 12 meters. The actual diameter of the sun, because if you haven't figured it out yet, I'm going to pretend that the orange julep is the actual sun. Well, the diameter of the sun is 1,392,700 kilometers. You don't have to know any numbers here, by the way. Just think of the idea I'm going for. So with that, I can actually calculate how big each of the planets would be if the sun were the size of the orange julep. So to do that, we do have to do a little bit of math. Yes, sir, we love math. I knew you'd say that. So let's go through it very quickly, I promise. So the diameter of the Earth is, I looked it up, 12,742 kilometers. And I really want to just show you one thing because this involves cross-multiplying, the greatest math trick ever. It gets you out of so many problems. Well, if this is 12-meter diameter at the orange julep, I'm going to say compare it to what it is in real life, the big number here. So 12 meters at orange julep over that number kilometers in real life. And I'm just going to build another little fraction to make it equal. X meters at the orange julep, if I want to find out how big the Earth is in my little model here versus what it is in real life. And if I cross multiply it, multiply the two diagonals, divide by the other number, I am going to get as an answer this, 0.11 meters, which is 11 centimeters, not 10, sorry for the typo, but about 10 or 11 centimeters. So all that to say, if the orange julep were this big, the Earth would be the size of about a cantaloupe, okay? Much, much smaller and quite far away. How far away? Well, that's what I also want to show you. Here's a Google image or satellite image of the orange julep, which is up to Kerry. By the way, whenever you look at something on Google Maps, there is a scale at the bottom. It is telling you that this space on the map equals 10 meters in real life. So we could do more cross multiplying if we wanted. I know you really want to, so, well, too bad I'm not going to. Here is the sun. Where would the nearest planet be? Mercury. Would it be where these cars are parked? No, it'd be a little bit further out. We'd have to zoom out quite a bit. So now we've zoomed out a lot, actually. It's pretty hard to see it. It's this little dot right here, the orange julep. Notice our scale has changed. Now this amount of distance represents 100 meters in real life. Well, if that's the sun, Mercury would be orbiting around the sun way out there, several blocks away. All right? It would take Mercury about 88 days to go around the sun, much faster than Earth. And Mercury would be about the size of a golf ball, several blocks away. Next planet, Venus. I've had to zoom out again to fit Venus on the map. So there's the sun. You can barely see that little orange dot now. There's Mercury. Here's Venus. And Venus would take 225 days to go around the sun. It'd be also about the size of a cantaloupe, a little bit smaller than Earth. Then we've got Earth out here. As you know, Earth takes 365 and a quarter days to go around the sun. Every 4 years, we add up that quarter and get one extra day, which is February 29th. This year was a leap year. About the size of a cantaloupe, like I said. Mars would be out here, a few blocks away again. And it would take 1.88 years, so almost 2 years to go around the sun. All right, the further out we go, the longer it's going to take for the planet to go around the sun. And Mars would be about the size of not really a baseball, but a softball, a little bit bigger than a baseball. Okay, next planet, Jupiter. By the way, we can see they're kind of about the same distance. We keep moving out about the same distance, but we're going to have to make a big, big jump. We're going to have to drive quite a bit down to Kerry to get to where Jupiter is and zoom way out. So I've zoomed quite a bit out now. There is the sun. There is Mercury, Venus, Earth, Mars. Jupiter is way out here. Okay, so it's crossing through the airport. It's just crossing into Laval. It's much, much further out. The asteroid belt would be somewhere in here. If you're driving down to Kerry towards the Champlain Bridge, it'd be where you get caught in traffic. So actually, that's everywhere onto Kerry. So there's Jupiter. It's the biggest planet. It orbits around the sun. It takes 12 years for it to make its lap. And it would be about the size of a very, very, very large beach ball. Look at how big that beach ball is compared to the person standing next to it. Next planet, I got to zoom out again. Now I can see the entire island of Montreal. So there's the sun. There is a certain high school you may have heard of. There are all the planets we've mentioned so far, Jupiter, and now Saturn would be way out here. It would be just as you come off the Champlain Bridge onto the South Shore. It would go well into Laval, well into the West Island. And notice the scale. Now, this distance down here represents 10 kilometers in real life. Saturn would be, well, it would take 29 years to go around the sun, and it would be about the size of another pretty big beach ball, not quite as big as Jupiter. Okay, next up is Uranus. Here it is way out here. It would take 84 years for Uranus to go around the sun. And let's see, it would be about the size of a basketball. Next planet is Neptune. It would go way out here. And it would take 165 years to go around the sun. Neptune would also be about the size of a basketball. And why not? We'll pretend we're back in the 90s and Pluto, it's not a planet anymore, but let's just see where it is just for fun. Although I'm not going to bother to zoom the map out to show you fully. Pluto would be around here. And it would take 248 years for it to go around the sun. And it would be about the size of a little tiny marble. So there we go. Those are the 8 planets plus Pluto, if you want to think about it, and where they would be going around the orange julep sun. There we go. So we've combined math, we've combined science, and we've even done some geography. How about that? So just for fun, where would the next closest planet be? Well, if we want to answer that question, we've got to do a little bit of work. So, and I don't mean Pluto. We still love you, Pluto, but not that. First question I got to ask you is, what is the speed of light? You don't need to know it by heart, but I'm going to tell you it is 1 billion kilometers per hour. I know 1,079,200,000, but let's just about 1 billion kilometers per hour. Fastest thing in the universe. So that means it would travel 1,079,253,000 kilometers in 1 hour. How far could light travel in a full year? If you figure out how many hours there are in a year, you can calculate this, and you would figure out that light in 1 year could travel a total distance of 9,460,528,405,000 kilometers. Really, really humongous distance. Okay, and the reason I've thought about that is because this gives us a new unit called a light year, and it's pretty convenient to use this unit if we're doing any kind of measurements in outer space, because they get so enormous that it's much easier to just say something is 1 light year away than something is this many kilometers away. Okay, so now I can finally tell you how close the next planet would be. By the way, a light year is a unit of distance because it's measuring how far something is. It's not a unit of time. It's not a unit of speed. Be careful. It's a unit of distance. So I can tell you that the nearest planet that is not in our solar system, called Proxima Centauri b, is about 4.25 light years away. In other words, take this number, multiply it by 4.25 if you want it in kilometers. There you go, over 40 trillion kilometers away. That would not fit on our little orange julep exercise. We would have gone way off the planet even through Google Maps. So that's about it. But before we go, just another version of this if you want. Bill Nye did a little thing like this where he biked the distance between the planets. I just sat here with my computer and used Google Maps. So a little easier. But you can check that out too. And there's a link in the description along with the If the Moon Were 1 Pixel. So your homework, check your email regularly. We're going to be we'll still go through some things. We'll try to do another Zoom class in the future. We'll do more labs from my living room as much as we can. If you're interested, try to build a Rube Goldberg machine. I know the government packs that some of you may be looking at sent that out as a challenge, but we are going to actually talk about them later on in the month. So, hey, why not? And because you now know that light years are units of distance, measure your height and tell somebody your height in light years. People always ask me how tall I am. And now, from now on, when they ask me, I'm going to throw them off by answering in light years. I looked it up. I am 1.99 times 10 to the minus 16 light years tall. That is 0.15 zeros, 199 light years. There you go. That's it for now. Have fun with this. Stay safe, stay positive. I look forward to seeing you guys on Zoom, and take care. And wash your hands.